looking at voice systems because many people think that if you do it by voice, it's going to be safe. And until now, there hasn't been a quantitative assessment of how much demand the voice interface puts on the person. So with the help of MIT, we're finding out exactly how much cognitive load a voice system has compared to doing it with conventional visual manual controls.
Next up is a distraction topic. Drs. Jim Foley and Brian Reamer. Brian is from MIT. Also, Dr. Bruce Mailer is with him and will be back at the booth. And Jim Foley is from TTC in Ann Arbor.
Thank you. And Brian Reamer's next to me from MIT. So this project, we're looking specifically at quantifying the demands of a voice-based in-vehicle interface. Many people assume as a countermeasure for distraction, if it's voice-operated, it's going to be safe because the people can keep their eyes on the road and hopefully thereby keep safe. So we're stressing the quantitative evaluation of a voice interface, which Brian will give you more details on in a second. Our goals are to develop such quantitative metrics for evaluating the cognitive demand of voice interface. We all know it's very hard to understand what's going inside of the wet computer, and what kind of measures can you extract that tell you about what's happening in the driver's mind. And we are consistent with CSRC goals of sharing our data. We have timed this study so that we will have results before NHTSA develops their guidelines for voice interfaces in 2014, and of course we will share. So I have an example on the next slide of demands of voice interface, and like any interface, it has to be well designed in order to work well. So this is not our data collection, but this is a clip from YouTube.
I don't think it understands Rockstation. I think if you say play CD, it might work.
Play CD.
Pardon?
Play CD.
Please repeat.
And so that's one of the challenges with voice interface. Now I'll let Brian explain more of the details.
So as Chuck started off, the real goal, one of the real goals of CSRC is to stand on research that's happened before. And this project in particular is really standing on some work that we've done at MIT over the last 6 or 7 years at developing procedures for assessing and grading cognitive workload. And the task that we're focusing on here is an NBAC, or a delayed digit recall task, that at the simplest set is just asking people to repeat a series of numbers while they're driving. And as many of you will experience later on, as even the moderate or the high demanding levels of that task, where you're asked to repeat just a number back in the sequence. So in the demo in the back of the room, which you'll experience shortly, the experimental voice says 6, you say nothing, the experimental voice says 9, you say 6, and so on. Just a little memory involved. It's quite complex while you're driving. It alters your behavior behind the wheel and how you look at the roadway. This task in particular is being used by the ISO community throughout the world, other labs. It's also been mentioned in some of NHTSA's reports last year, and Tom Ranney really addressed that the TUBAC, the most difficult level of this task, may be one that is first viewed as an acceptable dose of cognitive demand in the vehicle. So really, as part of the project that MIT and CSRC are involved with, trying to leverage upon this to grade how difficult are different voice interaction techniques or tasks while we drive. In particular, the research over the past number of years is focused on eyes on the road. While we're looking at the road, that must be safe. Unfortunately, the more we think about while we're driving, the more that's altering how we're looking at the road. So it's looking at the relative demand associated with tasks such as engaging with the radio, selecting a song, or entering a navigation input while you drive, really a low demand, really a moderate cognitive demand, or really quite complex and a high cognitive demand. So we're really focused on evaluating that information, as well as looking at how traditional visual manual input might relate to more novel and new voice input. So entering a radio destination by pushing a preset or 3-step command. And then looking across physiology, visual attention, eye tracking, vehicle telemetry, task performance, and subjective assessment to really put a holistic picture of how things are working in the car. So the platform we're using to look at this data is really unique because it's bringing all these different metrics together under one roof. One of the few research vehicles in the world that's really equipped for its time-synchronized collection of visual attention, eye tracking, vehicle physiology or driver physiology, vehicle telemetry, and environmental sensing, or cameras pointed at the world around us. So just to give you a flavor of what this task looks like, if you can play the video here, on the first here you'll hear a song selection task followed by an illustration of the cognitive benchmark or NBAC task, just repeating a series of numbers.
Your task is to play music by Johnny Cash. Begin.
Please say a command.
USB.
USB. Please say a command.
Play artist Johnny Cash.
6, 5,
6,
7,
5,
0,
7,
1,
0,
2,
1,
9,
2,
8,
9,
3.
8.
So the real vision here is how do you begin to look at a holistic way of optimizing the driver-vehicle interface. And if you want to learn more about the effects of how cognitive demand with one of these delayed digit recall tasks may impact your ability to react to the vehicle in front of you, I invite everybody here to come visit us in the back corner of the room afterward and see how well you can actually react to a changing brake light while you're thinking about something else besides driving. Thank you. So in the demonstration here, this is a simple reaction time task. We're looking to measure individuals or drivers' reaction time while just driving, and then reacting while they're also partaking in a moderately difficult cognitive activity. And what we see predominantly is that cognitive activity reduces the speed in which we're capable of reacting to a brake light or a vehicle in front of us. As Jim drives here, you're seeing that the brake lights on the yellow taxi in front of him are alternating between off and on. They go on, we're looking to get very quick reaction time. And we're moving on into the cognitive task here, and he's going to be asking to repeat numbers and react at the same time.
8,
4,
7,
5,
4,